Hi, welcome to Concept Based. I'm John Hepworth, and we are in a Year 11 Advanced Introduction to Differentiation section of the syllabus, and we are doing calculations with the derivative. I'm not sure why. I feel a bit mean today. I feel like this question is a bit of a step up from the previous videos that I've done already on differentiation. This one's an application question, and the syllabus does state that we should be examining and using the relationship between the line or tangent and its angle of inclination at given points and so on and so forth. So you are asked to do these types of questions. So let's go and have a look at it. It's going to have a few things in it that we haven't seen before. So hopefully we can apply some of the rules that we've learned in previous videos to this function, and away we go. Now, with my students, I often say, if you can draw the picture, draw the graph first. Now, when you're in Year 11 at this stage and you're just doing introduction to differentiation, your graphing skills aren't anywhere near as strong as what they will be in the end of Year 12. The reason why I would suggest just graphing it is because it gives us an idea if our answer is somewhat reasonable. But you may not be in a situation where you could graph this as of yet in the course. But I am going to show you what I would do so that when you're further on in your course, it's something that you might do as well. I would consider the graph root x, which looks a bit like this. I would consider the graph 2x, which looks a bit like this, and then we're adding 1 to it. And so then we're going to end up with some sort of function that sort of heads up in this direction, really quite steep. And you notice I've started it from x equals 0 because when we've got root x in the function, we can't have values less than 0 because then we would end up with an imaginary number. So what we can definitely see is that when we get to this point 1, 4, we're expecting that this function will be moderately steep, and it's going to have a tangent to this function that's going to create our angle of inclination over here. So we are expecting that we're going to see an angle of inclination somewhere, I'm guessing, between 45 degrees and 90 degrees. By the look of what I just drew there, like my rough approximation is 60 degrees. But I do know at least that it's first quadrant, that I should get a positive tangent, positive gradient on my tangent at the point where that intersects. So, and again, look how rough my drawing is. I'm not trying to draw it to really make it nice and clear. I'm just drawing it so that I have a concept of what this answer should be. Really, definitely, should it be positive or negative? Therefore giving me an obtuse angle of inclination or an acute one, I can see that I'm looking at something acute. All right, so next part of this question, we have this f of x equals root x. Now, we haven't seen root x in the videos that I've done with you previously. All we have done is we've just said, hey, when you do the derivative, all you do is you take the power, you multiply it by the front and drop power by 1. You still do that in this root x one, but we just really should be writing root x as x to the power of a half. So if you're not good with indices, it's going to impact your ability to do differential calculus. You have to be able to write these surds as indices so that you can go ahead and do the differentiation. So we then get a half x, and when we minus 1 from a half, we're going to get negative a half, so the indice gets a little more complex, plus, now this one, the power of x is 1, 1 times 2 is 2, we drop that power by 1 and we get 0, x to the 0 is 1, so it's just the 2 in front of the x. And then the constant term at the end, when we differentiate a constant, we get 0. Now we're asked what the gradient is at a given point, right? We have this point here, 1, 4, that we're trying to find the gradient at. Now, all we really care about is the x value in that point. That's what gives us the gradient out of our gradient function here. So we're just going to chuck 1 in to our function and see what we get. So 1 to the power of negative a half is 1. A half of 1 is a half, plus 2 is 2.5. So the derivative is equal to 2.5. I'm actually going to write that as 5 halves at the point 1. Now we now need to find this angle of inclination. You know, we've hit this curve, whatever it looks like. We've drawn a tangent and we've hit the x-axis, and we now need this theta component. So how can we find that from what we've got? Well, the gradient of a line is its rise over its run. So that would be a ratio of 5/2 here. And if we're after this angle, then we're dealing with the opposite side and the adjacent side. So there is actually a rule that the gradient is equal to tan theta. Now you should have seen this in stage 5 also. And so we can go and solve the angle by substituting our 5/2 as our gradient equals tan theta. And I will then do theta equals the inverse tan of 5/2. I'm going to do it in degrees, not radians. So I'll just make sure that that is correct in degrees mode. So inverse tan 5/2, and I get 68.2 degrees. What a fluke. My rough graph at the top is pretty good. So if I scroll back up to what I roughed out up here, you know, I sort of thought that would be about 60 degrees based on what this thing was looking like. And my answer is 68.2. So if I didn't do that rough sketch up the top, and I'm not good at graphing and I can't turn f of x equals root x plus 2x plus 1 into some sort of graph, how would we have any idea whether 68.2 is correct or not? We don't have any checking system. So being strong at being able to just rough sketch graphs, I think, is an excellent skill to have, because it backs us up even in calculus when we're trying to find solutions to tangents and so forth, just to make sure that we're on the right track. Now, if you felt that that question was a big step up from the previous video, I understand that. You might need to watch this again, but really the point that is in this question that I care about that you can do is this idea of doing the derivative of x to the power of a half. It could obviously be any index, x to the power of 3/5, x to the power of negative a half, anything like that. And just dealing with what comes from it after you do that derivative, and having negative indices, what does that mean, and so forth. So understanding your indices from surds is very necessary to help you do the derivatives. If you need to go back and revise that from stage 5 content, then I would recommend doing that, just to make sure that you're really comfortable with why root x is a half, or the cube root of x would be, you know, x to the power of a third.